In 4000 BC, the Mesopotamians originated the idea of dividing a circle into 360 degrees and then subdividing each degree into 60 parts they called minutes, and each minute was divided into 60 parts, which is called seconds. And 360 degrees was the annual motion of the sun, which took about 360 days. They also built the first observatories to observe the planets. They called these 7-layer pyramids structured observatories ziggurats. Around 3000 BC, many of the Egyptian temples and monuments, such as the Great Pyramid, were aligned to the cardinal directions. Others were aligned to the rising or setting of the sun at the time of the summer solstice. In 2400 BC, Stonehenge, the most obvious orientation is that it's lined up with the point on the horizon where the sun rises on the summer solstice. It was also used as a calendar. In 1300 BC, the Chinese recorded observations of about 900 solar eclipses and 600 lunar eclipses. They also recorded astronomical events such as meteor showers. In 585 BC, Thales could predict a total solar eclipse. In 582 BC, Pythagoras and his students created a model of the solar system. They also figured out that the planets were spheres, and figured out that they rotate in a circular motion around the central fire, even the sun. He also came up with the Pythagorean system. In 500 BC, the Babylonians discovered each planet's synodic period. They looked at astrology and had the belief that the positions of objects in space influenced events on Earth. They also had the ability to predict celestial events. In 355 BC, Aristotle proved that the Earth was a sphere by its reflection on the moon, and that the core of the Earth has a pull on everything. He also predicted that the Earth was the center of the universe. In 310 BC, Aristarchus showed that it was possible to use geometry to find the distance to the moon, but in order to do so, he needed both the moon's angular and linear diameter. In 276 BC, Eratosthenes used geometry to calculate the size of the Earth. He used land objects to do so. He figured that a cart was about 25,000 miles. In 134 BC, Hipparchus made the earliest systematic catalog of the brighter stars, found out that Earth had a rotational axis that estimated shifts of the vernal equinox by about 1 degree every 78 years, and completes a full 360 and 28,000 years. 2,000 years ago, the Mayans and the Mesoamericans built buildings that aligned to position of the sunrise and sunsets of the equinoxes and solstices. They also cherished Venus, and when it was war, they used it for direction. The Mayan calendar kept track of not only the sun and moon, but also the rising and setting of Venus. In 127 AD, Ptolemy made a completion of a system that could accurately account for the motions of the planets using a combination of regular circular motions. He had his own solar system theory. It was his geocentric model of the solar system. In 700 AD, Arabs improved many observing techniques and improved ways in which planetary positions were calculated. In 1473 AD, Copernicus proposed the first fully heliocentric model of the solar system and figured out the sidereal and synodic periods. And he also found out how to find the UA of planets. All right. In 1583, Brahe wrote a book about his observations of nova. He also made astronomical instruments and rejected the heliocentric model, and was particular in the stellar parallax. He said that the sun and moon orbit the earth while all the other planets orbit the sun. In 1593, Galileo made his own telescope and found out that the moon had mountains and valleys and plains. He drew precise diagrams of the moon and sun and figured that the sun had dark spots and that it had rotated once every 4 weeks. He also made observations about the phases of Venus. In 1602, Kepler created his own laws of planetary motion. In 1705, Newton created the laws of motion. He also figured out that the bigger the force or object in space, the more of a gravitational pull it has. This theory is called the universal gravitation. He also showed that the laws governing astronomical bodies are the same as Earth. In 1706, Edmund Halley, an English astronomer who was the first to calculate the orbit of the comet later named after him. He also devised a method for observing transits of Venus across the disk of the Sun in order to find out the distance from Earth to the Sun. In 1915, Einstein created the general theory of relativity. According to this theory, mass and energy determine the geometry of space-time, and curvatures of space-time manifest themselves into gravitational force. In 1922, Niels Bohr contributed to the quantum theory. He also developed a Bohr model of an atom. In 1933, Wolfgang Pauli proposed neutrino astronomy as a solution to the missing energy problem to the beta decay. He also created up with the Pauli excursion principle. In 1937, Werner Heisenberg started the famous uncertainty principle. In 1929, Edwin Hubble discovered that the faraway galaxies are moving away from us, known as Hubble's law. The theory is that galaxies recede from each other at a proportional rate to their distance from each other. In 1930, George Lemaitre discovered the expansion of the universe called the Big Bang theory. He also went off of Einstein's theory and made his own predictions. In 1935, Robert Oppenheimer calculated the properties of a star made entirely of a gas of degenerate neutrons. He was also called the father of the atomic bomb. In 1939, Fred Hoyle disagreed with the Big Bang theory and said it's very unlikely to happen and came up with a few of his own theories. He was primarily noted for his contribution to the theory of stellar nucleosis. In 1964, Penzias and Wilson, the inventors of the cosmic microwave, had evidence of expanding the universe. The cosmic microwave background radiation was the radio remnant of the Big Bang theory. In 1969, Armstrong and Aldrin were the first men on the moon. They helped design the X-15 rocket plane and also collected samples from the moon. They were also the first civilian astronauts to fly in space.